Okay, so here the light ray which is coming like this here the light ray which is coming like this. Next, after this light ray, and this is the angle of incidence, this angle which is I, and so this is a normal. Now this light ray will get deviated from its original path. Actually the light ray want to go in this path. Actually this light ray want to go straight path like this, want to go. But because of the medium changes, the light ray will get deviated. It will move either away from the normal or towards the normal. When the light ray is moving from one optical medium to another optical medium. Fine.
Yes, sir.
Yes. Copy it now?
Yes, sir.
Now. So basically the refraction of light is because of the change of speed of light. Speed of light is different in the different medium. In air, what is the speed of light? In air, speed of light will denote as a c, and that is how much this value? 3 into 10 power 8 meters per second. This is the speed of light in air. And if the medium changes, speed of light is also changes. And maximum speed of light is only happens in air only, that is 3 into 10 power 8. The speed of light is low in case of a denser medium. In the denser medium, speed is low, and speed of light is high in case of a rarer medium. Okay. When the light ray will get refracted, and the most important thing is frequency does not changes. Frequency of light remains same. And phase, these two terms do not change. But what changes? Wavelength will changes, velocity also changes. Wavelength will changes, velocity also changes. And so if I say c is the velocity of light in air, the velocity of light in some other medium that is less than the velocity of light in air. If the velocity of light is high, we can say that is a denser medium. If it is low, means we can say it is a rarer medium. And another phenomena is light which is always bends towards the normal. That means towards the denser medium it will bend. It will bend towards denser medium. So you can treat as a denser medium will attract the light ray. Denser medium will attract the light ray. So you can see now here, for example, we have taken the two mediums we have taken, and this is a normal. So we have considered this is right, and this is a normal. Now let us consider here, this is a rarer medium, and this is a denser medium. The light is moving from the rarer to denser. Let us say the light ray which is fall at this location. The light ray will fall like this. and this is the incident ray. Now it is moving into the denser medium. So you tell me now here what happens now here. How this light ray, the actually this original light ray, it want to continue in the same path, want to continue like this. This is the original light ray want to go like this. So this is the angle of incident, that is I. This is my total angle, and which will be equal to what you tell me now. This is I. Okay. The light ray will continue. But here what happens now here? The light ray want to go like this, but the denser medium will attract the light ray. Instead of going away, it will attract the light ray. So then as a result, the light ray instead of going in this direction, this light ray will bend like this. This light ray after coming here, it will bend towards a normal will bend. Understood what I'm saying?
Yes, sir.
So this light ray will move like this, and this is the angle of incidence. Now this ray, this is my refracted ray now. This is the refracted ray, right? Now this angle, which we are calling it as a angle of refraction R. Okay. So in this case, what you observe now here, when the light ray moving from which to which medium? Rarer to denser, the light ray will bend. Which direction now? Towards a normal or away from normal?
Towards the north.
Towards a normal, the light ray will bend. Now, let us consider some other situation. Now, so we have considered this is a denser medium. And we have taken this is a rarer medium. Now let us consider the light rays coming like this. Now here this light ray want to continue in the same path like this. And this is the angle of incidence, which is equal to I. Now this is the angle of incidence I. Light ray want to go like this. But because of the medium changes, what happens to the light ray? Will bend. Which direction the light ray will bend? You see this thing, denser medium will attract. Actually the light ray is going here because this denser medium is above now. This denser medium will attract the light ray towards. Okay, so that's why what happens now here, the light ray, it will move like this. Okay. Now this is called as an angle of refraction now. This is the angle of refraction R. Okay. Now in this case, what happens to a light ray? It is moving towards a normal or away from normal?
Away from the normal.
Away from normal. Right. This way. So here when the light ray when the light travels from rarer to denser, it will move which direction now here? Towards a normal it will move. But when it is moving from denser to rarer, it will move away from normal. Okay. Done.
Sir, 1 minute.
Yeah.
Done, sir.
Right. Copy this also.
Yes, sir.
So now you can see now here. Here earlier we have discussed about the deviation in case of a reflection we have seen. Now we are talking of the deviation for the refraction now. Refraction case. Here look at now here. Actually the light ray, this is want to go in this path. And but there is some deviation now. This light ray will bend towards the normal and this angle is called as an angle of deviation now. Okay, now can you tell me now deviation in this case? The deviation now, how much this angle?
R plus, sir.
This angle is what? I na this total angle, this is the actually. So this ray, what is this ray here? What is this one? This is the incident ray want to go like this or not?
Yes, sir.
Yeah, this angle is I, so that means this angle is also same I only na.
Yes, sir.
So this is the now refracted ray, this angle is what R. Now we need the deviation now. Deviation means this angle, right?
Yes, sir.
How much this angle?
I minus R.
Yes, so that is deviation which is equal to I minus R. Right. Now tell me now here. In this case, here actually the light ray want to go in this line and the light ray will get deviated. So this much is the deviation. Now you tell me now angle of deviation in this case. How much?
R minus I.
R minus I. Okay. If the light ray is deviated away from normal, R is more, that's why R minus I simply. Bigger minus smaller, simple thing we can say. Right?
Yes, sir.
Now let's talk about the refractive index. The next one, refractive index. Refractive index, it is nothing but one parameter which will measure the density, optical density of a medium. To measure the optical density, we use a refractive index is useful. And how the refractive index is defined as a the refractive index, and which symbol you are following the refractive index, N or mu?
Sir, mu, sir.
Okay, mu, fine. So the refractive index of a medium we are denoting with a. Some books they will follow N notation also. So that is mu, which is given as, this is the ratio between velocity of light, or we can say speed of light, we can say speed of light in air by speed of light in medium. Okay. Speed of light in air by speed of light in medium is called as a refractive index. And so that is given as speed of light in air. How much is value? Which is equal to 3 into 10 power 8 by speed of light in medium. Velocity, speed of light in medium, which will be, I can write this as, so this is C by V we can say. Where C is what, tell me now? C is equal to speed of light in air, it is given as 3 into 10 power 8 meters per second. And speed of light in a medium is 3 into 10 power 8 by, this is square root of mu r into epsilon r. Okay, square root of mu r into epsilon r. Here, what is this mu r, epsilon r? You need to understand. Where this mu r, you will get to know later. Mu r is called as a relative permeability. Relative permeability. Epsilon r is called as a relative permittivity. Okay. Now, refractive index, which will be given as what you tell me now here? Speed of light. So this is 3 into 10 power 8 by, this is what I mean now, 3 into 10 power 8 by, that is square root of mu r into epsilon r. 3 into 10 power 8 will get cancelled. Then it will come to be a what? This is mu r into epsilon r. This is the refractive index of a medium. Okay.
Yes, sir.
Now, so finally we can say the refractive index. Refractive index, that is mu formula, which is equal to square root of mu r into epsilon r. Right.
Yes, sir.
Let's see the some of the properties of refractive index. Copy it now?
Yes, sir.
Yeah. Refractive index is a scalar quantity. Refractive index is a scalar quantity, and the refractive index has no units and no dimension. It is a dimensionless quantity. If the refractive index is high, then we can call that medium is a denser medium. Refractive index is high, then we can call it as a denser medium. Refractive index is low, then it is a rarer medium. It is a denser or rarer based upon the refractive index will decide. Okay, so So the speed of in any medium which is given as what? Speed of light, which is equal to speed in air, that is c, 3 into 10 power 8 by refractive index. C is the velocity of light in air. Then the speed in medium is given by c by mu. Mu is a refractive index. And wavelength. Lambda is given as what will be now? Lambda naught. Lambda naught by mu. Lambda naught is a wavelength in a air. Mu is a refractive index of the corresponding medium. So as a result, so then in case of denser medium, speed of light is low. So denominator will increase now. That's why speed will decreases. Wavelength also decreases. But frequency remains constant. Velocity, wavelength will changes, but frequency remains constant. And the refractive index, so first we can see now air, vacuum, free space, all are same meaning. Air, vacuum, free space, refractive index is 1. This you need to remember. This water, these things are no need to remember. This is just for your reference only. Water 4 by 3, glass 3 by 2. In the problem, they will mention these values. Okay.
Yes, sir.
Next one. A relative refractive index. A relative refractive index means we'll talk about refractive index of one medium with respect to other medium. A relative refractive index we can say. Now, so if we talk about the refractive index of medium 1 with respect to second medium we are talking. This how will denote now we need a refractive index of which medium? First medium, that should be written front side, and that is with respect to second medium that will be written back side. Refractive index of medium 1 with respect to medium 2. We can say this as, we can pronounce it as mu 1 2. आगे 1 पीछे 2, mu 1 2. So this means this is what will be now mu 1 by mu 2. Refractive index of medium 1 with respect to second medium. Next, refractive index of a second medium with respect to first medium. I need a refractive index of a second medium, second medium I need, that is with respect to first medium, that is 1. Yeah, so that should is given as what we can say now here, that is mu 2 by mu 1. Okay. This is called as a relative refractive index. They will ask refractive index of water with respect to glass, refractive index of some mica with respect to glass. They may ask like that. Those cases we use a relative refractive index. Right. Next, if we see here 1 to mu 1 2 into mu 2 1. See what I will get now. Hmm? Mu 1 2 into mu 2 1.
Sir, 1.
Yeah, so we'll come it as 1. We're multiplying now, will get cancelled, will come. So from this we can write it as what will be now mu 1 2, which is equal to 1 by mu 2 1, right? Mu 1 2 equal to 1 by mu 2 1. Okay,
Yes, sir.
done now, copy.
Yes, sir.
Next one. Laws of refraction. Previously we have seen laws of reflection. What are the laws of reflection? And what are the laws of reflection we have seen in?
Angle of incidence, angle of reflection, and angle of and normal lie on the same plane. Angle equal to angular.
Yes, so that's the that is laws of reflection. Now, laws of refraction also almost similar. Look at now here. Here earlier we talk about the incidence angle. So incident ray, reflected ray, normal. Here we should talk about the incident ray and the refracted ray, and this is normal. All these will lie in the same plane at the point of incidence. Okay. Next, the another one. Yes, look at now here. This is a medium one. This medium refractive index is mu1. And the second medium, this refractive index is mu2. The second law is, what tell me now? So here the refractive index of this medium, incident ray, having this is mu1. What is the angle of incidence here? I na. That is mu1 into sine I. Right. Next, come into refracted ray. In this medium, refractive index is how much now? That is mu2. Angle is how much now? R. That means sine of R. Sine R. R equal. Okay. So that means what we can say now here, this is the product of refractive index and sine of angle with the normal remains constant. Okay. Mu1 sine I equal to mu2 sine R. This is the second law. And this is also called as a Snell's law. Have you heard this name?
Yes, sir.
This is called as a Snell's law. Right. So here this Snell's law. So it will be for every problem we can almost use a Snell's law. Right. So every problem this is helpful. Remember. So from this we can write it as sine I by sine R, and which is equal to what tell me now, mu2 by mu1, mu2 by mu1. And this can be also written as velocity in a medium 1. How we can write, you tell me now? That is given by c by mu1, right?
Yes, sir.
Yeah, from this what we can say, this is mu1 is equal to, we can write as c by v1, we can write now. And similarly mu2 equal to what we can say now, that is c by v2 I can say. Now from this what I can say now, mu2 by mu1, tell me. Mu2 which will be given by c by v2 by what we can say now, c by v1 I can say now.
V1 by V2.
Yeah, so I will come it as what will be now, v1 by v2. and that is also can be written as velocity directly proportional to wavelength. V is equal to F into lambda, frequency constant. Okay, V is equal to velocity equal to F into lambda, velocity directly proportional to wavelength. Then we can also can be written as what, tell me now, lambda 1 by lambda 2, right?
Yes, sir.
This is the laws of refractions. Now let us see when the light ray does not have any refraction, no refractions. The light ray doesn't have any refractions in two cases. Two cases. Now look at now. What a refraction means basically?
Sir, deflection of light when it
Yes,
changes mediums.
medium. That is another deviation we need. So yeah, you see this thing. We have seen a Snell's law that is given as mu1 into sine I equal to what, tell me now, mu2 into sine r. Fine. So let us consider here now if so, as we have seen the deviation, that is which is given as simply I minus r, r minus I, we can write now. Now you tell me now here, if mu1 and mu2 both are equal, what happens, tell me? What happens? Mu1, mu2 both are equal, what happens?
Sin I by sin I equal to 1.
That means what? Mu1, mu2 will get cancelled now. Sin I is equal to sin r.
Yes, sir.
Yeah, that means what happens now? Sin I equal to sin r only na. That means what
Yes,
happens now? I must be equal to r.
yes, sir.
So that is I is equal to r. Then what is the deviation now? Tell me now.
0.
Zero. Deviation zero means no refraction na.
Yes, sir.
Yeah. So in this case, no refraction. Next. Next now here. So let us consider if the angle of incidence I is equal to 0, tell me what happens. I equal to 0, then what is the R?
0.
I is equal to 0 means this is mu1 into sine 0, right? Snell's law. That is mu2 into what I know sine r na. That means
Yes, sir.
sine r equal to how much now? 0. That means r is also 0 only na. R is 0. In this case, how much the deviation now? Tell me now. This is I minus R, which is equal to 0 only now. There is no deviation, means there is no refraction. Okay.
Yes, sir.
Now that means the light ray doesn't have any refraction in two cases. Tell me now what cases now here. So if the refractive index of both mediums are equal, you see if mu1, mu2 both are equal, what happens? There is no deviation, right? In this
Yes,
case,
sir.
the refractive index of two medias are equal, then no deviations. And so if the I is equal to 0, I 0 means what? I angles are measured from where? Angles are measured from कहाँ से measure करेगा हमने? With respect to what we'll measure now? This is a line, and this line is called as what will be now normal na. Angles are
Yes, sir.
measured with respect to normal, right? So here tell me now, if the light ray is coming via this normal, then how much is I value, angle of incidence?
0.
0. Angle of incidence 0. Just now we have seen I 0. Whatever the R value 0, that means the light ray सीधा ऐसा जाएगा. It will straight away will go like this. The angle
Yes.
of incidence is 0. That means in this case also there is no deviation, right?
Yes, sir.
In these two cases, light ray doesn't have experience any deviation. Done?
Yes, sir.
Now, chalo, let's see some problems now. Tell me now. The refractive index of glass is given as 1.5. Then find the speed of light. What is the speed of light in any medium? Any medium speed which is given as what? Tell me now. 3 into 10 power 8 by mu na refractive index. Right?
Yes, sir.
So that
V
is
is equal
3
to
into 10 power 8 by refractive index is 1.5 given now. So this value 2 into 10 power 8 meters per second, right?
Yes, sir.
Next. The frequency of light in a medium is given, wavelength is given, refractive index they ask you to find. Frequency given. And the wavelength given. Wavelength is given as 5000 angstrom means 10 power minus 10 meters. Okay. Yeah, tell me now. What will do? Find the velocity now, speed now. Speed of light we can find.
Sir, I forgot the relation between wavelength and frequency and velocity.
Yes, velocity which is equal to simply f into lambda. Okay. Velocity equal to f into lambda. How is this formula?
Yes, sir. It was in grade 9. Actually.
F into lambda f. So tell me now f. We will come to be how much now? 2 into 10 power 14 into what? Tell me now, this is 5000 into 10 power minus 10. Tell me the speed now. So now check for the zeros cancellations now here. So 3 zeros again, 5 into 2, one more zero will come, 4 zeros. It will become, so tell me now here. So 10 power 18 will come. 10 power 18 minus 14 na, sorry 10 na. So this will come to be 10 power 8 meters per second.
Yes, sir.
Now this is the speed. What we need to get now? Refractive index we need to get now. So that means how will we find the refractive index of any medium? So speed in any medium is given by what? Tell me now here. That is 3 into 10 power 8 by mu, right? So that is mu is given by, so that is 3 into 10 power 8 by V. So from this get it now. 3 into 10 power 8 by P value 10 power 8. So it will come to be a 3. And what are the units of refractive index? Units of refractive index.
Sir, it has no unit.
No units, keep in mind. Next one. Find the time taken by the light to cross a glass of thickness 4 mm having refractive index 3. Hmm. Now, a glass of thickness of a glass is given as a 4 mm, right? And this, if I say D, which is given as a 4 mm. And the light ray which is passing through this glass. Yes. Now let us see if the speed is V. Now tell me now time taken to cross. Time is equal to what we can say now here, simply D by V. T is equal to D by V. So yeah, you tell me now T is equal to D. How much the D means? What are now total length na thickness. So here we will find the speed first. Can you tell me the speed of light in this medium? That is given as 3 into 10 power 8 by refractive index of this medium na. That is
Yes,
given
sir.
as 3 into 10 power 8 by mu value 3 given. So that is how much now? 10 power 8. So meters per second. So the time t is equal to how much now? D. D is a 4 mm. That is 4 into 10 power minus 3 by speed 10 power 8. So simplify and get it now here. 4 into 10 power minus 11 seconds now.
Yes, sir.
Next. A beam of light is refracted from vacuum into a medium of refractive index 1.5. Okay, the wavelength of the refracted ray. What should the wavelength of refracted ray? They are asking. What is the wavelength in a medium? First of all, that is given as wavelength in air by refractive index. Yes or no? Now this lambda naught is a wavelength in air. Air by, that is lambda naught by refractive index is 1.5 now. That means which is greater? Lambda greater, lambda naught is greater.
Lambda.
Lambda, no, lambda. Denominator is 1.5 na.
Yes, sir.
Now if the denominator is there, so that means lambda naught is greater than lambda less than lambda naught.
Sir, I didn't understand.
So here lambda value given as lambda naught by 1.5 na.
Sir.
So that means lambda value we are dividing the lambda के लिए lambda naught को 1.5 से divide करना.
Yes, sir.
If you divide now here this value less होगा ना, lambda naught से कम होगा कि ज़्यादा? It will be less only
Okay,
ना.
sir.
Done.
Understood, sir.
Yes, so that's why it is smaller. Refractive index of the refracted ray is less than the, so wavelength is less than of the refracted ray is less than the incident ray. Okay.
Yes, sir.
Next one. The velocity of light in water is given. Velocity of light in glass is given. They ask you to find the relative refractive index of water with respect to glass. Now, so we have the speed of light in a medium is given by what? Tell me now. 3 into 10 power 8 by the refractive index na?
Yes, sir.
Now from this mu is equal to what I can say now, this is 3 into 10 power 8 by V. This is the first thing.
Yes, sir.
Now if I say this as a refractive index of water, which will be given as what I can say 3 into 10 power 8 by velocity in water, and refractive index of a glass, that is 3 into 10 power 8 by velocity in a glass. Right. Now they ask me to find what? Tell me now. Refractive index of water with respect to glass. That means refractive index of water with respect to glass we need now. So if you take a ratio, then it will come to be what? Tell me now here. Velocity in glass by velocity in water will come. Glass velocity 2 into 10 power 8 and water velocity 2.25 into 10 power 8. Yeah, simplify now here. Refractive index of water with respect to glass. So which I can say this as 200 by 225 we can say. Now here this is 25 eights na, 25 nines. So this value given as 8 by 9.
Yes, sir.
Copied na?
Sir, 1 minute. Yes, sir.
Next one. Wavelength of light in air is given. A refractive index of diamond is given. Wavelength of the diamond E in diamond is. Yes, wavelength in any medium, which is given as what? Lambda naught by mu na.
Yes, sir.
So lambda naught, how much given? 4800 angstroms by, this is 2.4. So how many times?
2000.
Yeah, so 2000. So this is 2000 angstroms. right?
Yes, sir.
Hmm. What's the answer?
Where I got mu4 by mu1.
Mu4 by mu1. Yeah, then thereafter further simplifications. Mu12 into mu23 into mu34. Yeah, so that is nothing but mu1 by mu2. Next, this is mu2 by mu3, and this is mu3 by mu4. So then this is what, tell me
So
now?
option 3.
Mu1 by mu4. Yeah, so this we can write as what, tell me now? Mu14. Is a mu14, but option, no option. Nah. This can be written as what, tell me now? 1 by mu4, what we can write?
Yes, sir.
Yeah, so option 3. Next. A ray of light passes normally through a slab of thickness of refractive index is given. Okay. Thickness is a T they given. The speed of light in the vacuum is C. The time taken by the light ray to cross the slab. Tell me. Thickness of the slab, that means length of the slab, which is given as a T. The refractive index is given as 1.5, and this thickness, which is given as a T. So if we call the speed in this medium is V, let's find the speed in the slab. Yes, speed which will be given as what we can say now, C by 1.5, and which will be equal to C by 3 we can say. Now time taken, how much the time is given, time which is equal to distance. Distance is given as T given as T by V, which is equal to what, tell me now, 2C by 3 by V. Thickness is T only, na? Thickness is T by, this is 2C by 3. Then how much the time now here? 3T by 2C. Option
Yes, sir.
2. Next. Angle of incidence on the surface of a diamond of refractive index 2.4. If the angle between the reflected and the refracted rays is 90 degrees. Understand the problem? Yes, this is the light ray which is incident ray, and this is a reflected ray, and this is a refracted ray. Okay, so this is the incident, this is reflected, and this is refracted. Okay, now this is the angle of incidence I. Angle of refraction equal to angle of incidence only. Now this is I, and this angle is R. Okay, and so this medium, the light ray not mentioned, assume that light ray is falling from air to diamond. So here this refractive index of this medium, air medium 1, this refractive index is given as a 2.4. This is the data they given. Understand what they given?
Yes, sir.
Now tell me now what we can do and what the information they given. Hmm. They given this as a reflected and refracted rays. How much the angle?
90.
So that means they given this angle given as how much this angle is a 90 na?
Yes, sir.
Now you tell me from this what I can say now. This is I plus 90 plus R equal to how much?
180.
Yeah, so from this we can say now I plus R equal to
90.
yeah, so that means from this we can say now R is equal to what we can say 90 minus I.
Yes, sir.
Now let's apply the Snell's law. Yeah, tell me the Snell's law. That is what I'll now mu1 into sine I equal to mu2 into sine R. Mu1 means first medium refractive index, medium is 8 na, refractive index is 1, sine I, and mu2 that is 2.4 into sine R, that is sine of 90 minus I. So that means what we can say now sine I, which is equal to 2.4 into sine of 90 minus theta.
Cos theta.
Yeah, so this value cos theta na, that is cos I. Take the cos to this side. Sine by cos will becomes as tan I. Tan I is equal to 2.4. So finally we get this I value as what? Tell me now. Tan inverse of 2.4. This is the angle of incidence. right?
Sir.
Yes, first option. Done.
Yes, sir.